Hello students, welcome back to my channel Maths Insider. In the previous video we learned about Euclid Division lemma. Today we will learn about finding HCF highest common factor using Euclid Division Algorithm. What you will learn from this video, what the Euclid Division Algorithm is, how to find the HCF step by step, and how to solve exam question easily. Let's begin. What is HCF? It is nothing but highest common factor, and this highest common factor means the largest number that we divides two numbers exactly. So if there are two numbers, the HCF of the two number is the highest number or the largest number that it will divide exactly. So for example, HCF of 12 and 18 is 6. How we'll find it? Now normally we find the HCF between these two numbers using the factorization method. Let's use this method to find the HCF. So factors of 12 are 2, 2 and 3, and how we are finding? By simple division. Similarly, the factors of 18 are 2, 3 and 3, and also we'll find by the simple division method. So we are finding all the factors of the 18 and 12. Now what are the common factors of 12 and 18s? Which is 2 and 3. So 2 and 3, these are the common factors. So HCF of 12 and 18 is multiplication of 2 and 3, which is 6. So that is the factorization method. But when the numbers are quite big, when the two numbers are very big, then using factorization will be difficult. Then we will use this Euclid division algorithm to find the HCF very easily. It will be very simple and it will be easy to find the HCF between these two numbers. This method is also faster and easier. So now we will see how we can use this Euclid division algorithm to find the HCF of two number. So this Euclid division algorithm is the step-by-step method to find the HCF. Now let's see what are the steps that are involved in this Euclid division algorithm. So first, step number 1, divide the large number by the smaller number. So now between the two number, take the large number and divide it by the smaller number. Step number 2, what we will need to do is that take the remainder after the division. Now step number 3, now we have to divide the divisor of the previous step by the remainder of step number 2. So step number 1, what is the divisor, and step number 2, what is the remainder? We have to again divide, and this process will continue till we will get the remainder as 0 or when the remainder becomes 0, and this step continues till this remainder becomes 0. And so when the remainder is 0, the last divisor which is there is the HCF between the two numbers. So it's so easy. Let's take an example and use this division algorithm to find the HCF. So let us find the HCF of 135 and 225. So these are two bigger number, and it is very difficult to do the factorization and find the HCF. So let's find using this algorithm. Step number 1, divide the bigger number, which is 225, by the smaller number, which is 135. So we are dividing 225 with 135, and we will get 2 to 5 is equal to 135 times 1, which is nearest, plus what is the remainder? 90. Here, if you remember, in the previous video we have explained about Euclid division method, and we are using here to find the quotient, remainder and the divisor. You will find A is equal to B times Q plus R, which we have already discussed. So here in step number 1 we have a remainder is 90, and what is the divisor? 135. So step number 2, we have to take the divisor, that is B, and the remainder, that is 90, that is R, and you have to divide 135 by 90 as per the algorithm. Again we will get 135 is equal to 90 times 1, which is nearest, and what is the remainder? 45. Again we are using the Euclid division lemma to represent this 135, and from where we find the remainder and the divisor. So remainder is not 0, it is 45. We have to again continue step 3. So now we have to divide number 90, which is the previous divisor, and with the remainder, that is 45, from step 2. So we get 90 is equal to 45 times 2 plus 0. Now 90 is exactly divisible with 45, keeping the remainder to be 0. So we'll stop the algorithm here. So step number 4, what is the last divisor in step number 3? This is nothing but 45, because in this particular step number 3 we find that the remainder is 0. So the last divisor, as we have discussed, will become the HCF between the two number for which we have done this whole step-by-step method. So 225 and 35, the HCF of 225 and 35 is equal to 45. This becomes so easy, right? Now what is important exam tips? Now we'll use this algorithm first of all not on all the numbers, but when the numbers are very big. When the numbers are small, we'll use the factorization method. But when the numbers are very big, and if we want to find the HCF, then this particular Euclid division algorithm will be very handy. So how to do it? Write each of the division steps cleanly so that you can able to obtain the divisor and the remainder, and from that you will move to the next step, and you will use the Euclid division lemma for each of the steps to find the divisor and the remainder. Use the formula till the remainder is equal to 0. Write the final answer properly, and this will give you the HCF for the two number. Now let's quickly revise what we have learned so far. So to find the HCF of two bigger number or numbers using the Euclid division algorithm, and so we are using the Euclid division algorithm to find this HCF of the bigger number. And what are the steps? Divide the larger number by the smaller number. Then number 2, continue this whole process of dividing until we get the remainder becomes 0. And thirdly, the last divisor of this process becomes the HCF of two number. It's so simple. So in the next video we will learn more about how to prove the fundamental theorem of arithmetic. Thank you, friends.